It is so huge. It is an enormous engineering undertaking.
We're talking about putting solar arrays into space that are square kilometers in size.
Just to give you a sense of scale, each of these little disks is about the size of a football field.
This is a project that could be comparable with the Apollo program. This is something that's going to require a national commitment, a national level of effort.
We've never built massive structures of this scale before. We've never solved our space lift problem. Rockets are so expensive.
Getting into space has got to become cheaper, but that's where space solar power plays a role, in that it's a grand endeavor that will allow us, or actually require us, to fly to space not on dozens of times a year, but hundreds and thousands of times a year, such that the economies of scale kick in and it becomes cheaper.
It's going to require fleets of reusable spacecraft.
I envision standing out on a flight line and looking down the flight line at fleets of reusable launch vehicles.
You could launch a solar power satellite per week. That would be roughly equivalent to 100,000 megawatts, 100 gigawatts of clean solar energy, almost without limit, added to the global energy supply every single year.
Space solar power is something that has been looked at for the last 40 plus years, and it has, over the years, sort of fallen between the cracks. One of the obvious organizations that could be doing this is NASA. Another obvious one is the Department of Energy. But NASA says we don't do energy, and the Department of Energy says we don't do space. So they talk past each other.
We're really looking for private industry to ultimately be the builders, the owners, and the operators of these systems.
What the military and the government can be is an early adopter, an early customer, and help to field some of these demonstrations and some of these further studies. Putting a substantial demonstrator aboard the International Space Station would have a huge impact on making the next domino fall to make space solar power happen.
In order to progress in space solar power, there's going to be a need for certain demonstration.
My name is Amy Hurley. I work at the Naval Research Lab in the Naval Center for Space Technology. People come to the lab with concepts that need to be demonstrated.
My name is Paul Jaffe. I'm an electrical engineer for the Naval Center for Space Technology. We've worked closely with John Menkins and Pete Garretson, Paul Dampus and Coyote Smith to work towards a viable path to develop prototypes, test ideas. When you put a satellite in space, there are many differences between how it's going to operate on Earth and how it's going to operate in space. It's extremely important for us to simulate those on the ground beforehand so that we have assurance that it will actually work in space. Behind me is our thermal vacuum test chamber. We use this to simulate the vacuum of space. When we're going to run a test, we take the satellite, or sometimes just part of a satellite, we'll put it in the chamber, close the door up. We then use mechanical pumps to suck out a lot of the air, and then we use cryogenic pumps that actually freezes the remaining air particles onto a plate, which gives us a nice vacuum in there, simulates space fairly well. For space-based solar, we would definitely want to test the components that we would use in here, because they're not only going to need to be able to withstand the vacuum of space, but also the temperature variations. We're here in our anechoic radio frequency test facility. Anechoic means without echo. So when we're in this room, it's almost as if the room doesn't have walls because there's nothing for the radio waves to bounce off of. When a radio wave comes in here, it actually bounces off and ends up being directed back into the wall. We end up with no reflections, and it's a good simulation of space. For space-based solar, we might illuminate one side with the sunlight or simulated sunlight, and then measure the kind of antenna pattern that we get out of the back.
One of our objectives is to develop appropriate robotic assembly techniques.
What an autonomous robot does is it actually thinks for itself. It makes decisions based on things that it senses and sees.
What we could see are exceptionally large systems in space, like solar power satellites, that essentially assemble themselves.
Because it's in our history, and it is in fact our mission, to develop technology for space, this is a great fit for us.
I think the idea of having our energy source beamed down from space could seem incredibly outlandish to many people. But to a younger person, I would think that they would say, why not? This is a whole new generation that is used to using technology in every single aspect of their lives.
It's going to be the new generation of students coming through the system now that are going to be the engineers, the designers, the builders of these systems.
Ever since high school, I was developing an interest in doing engineering. I was also developing an interest in doing something that would benefit other people in the world.
Students need to take a look at engineering, at science, at math.
Diameter of the transmitter times the diameter of the receiver.
Certainly it all starts with those science and engineering and math courses.
This is about 2.45 gigahertz in terms of the frequency.
It could be 10 years into your career and something you learned in college is applicable and helps you understand someone else's job.
There are real opportunities for trying to make adjustments in these parameters in future designs.
The sciences and mathematics are the basis for doing all of the things that make other people say, golly, how did they do that?
There's times in school where you have to do things that you aren't really excited about, but they might help you do something later that you're excited about.
Things like mathematics and physics and engineering, the hard scientific subjects, those are the subjects which are going to be of the most use to you in getting a job, whether it's on the Earth or in space.
We're going to see that space is for business.
It would be a global business.
Of the known jobs that would be created by space solar power, there'd probably be about 1.2 million new jobs.
Electrical engineers, aerospace engineers, mechanical engineers.
We need a lot of people that have trade skills. We need people like metallurgists. We need people that have studied welding.
There's certainly going to be opportunities for folks to fly into space, not only for the fun of it, but to get paid to do it as well.
I can't think of a more ambitious project that a young person could make a larger mark on than getting us towards solving a problem like this with our long-term energy crisis.
I want people growing up in the remotest parts of the world knowing realistically that they have a path to maybe become part of the space program that's doing space-based solar power.
The difficulty is the loss of willpower. The loss of a clear understanding of how to go from A to B with the greatest economy and the greatest speed. We had it in the Apollo days. I hope that we can regain it again in a good cause, which is the cause of improving the condition of all of humanity by providing them with inexpensive, clean, renewable energy. I hope that because of that drive, we can recapture that sense that we've got to go do it, and the best way to do it is quickly.